Hello everyone, welcome to Chapter 3. This is the beginning of Semester 2, Lesson A on degrees and radians. So degrees and radians are different ways to measure angles, and you're probably most familiar with degree measures, but radians is a separate method or way to visualize the measure of an angle. So the objectives for today are the properties of angles, complementary, supplementary, and coterminal angles, as well as converting angles from radian to degree and back. And then finally, some work with arc length. So let's go ahead and get started with our first slide. Okay, so this page is packed with some vocabulary. I'd like to just talk through some of it. An angle is, at least on the XY coordinate plane, typically you'll see the vertex, right? Here's the vertex of an angle, where the two rays here, we've got a ray on the initial side and an array on the terminal side. The vertex is the point that connects those two rays. Okay, typically the vertex on the coordinate plane will lie right here at what's called the origin, 0, 0. And in standard position, this is an angle in standard position because its initial side lies on the positive x-axis, okay? So then we take this angle of rotation, which this would be the measure of our angle, right? This rotation right here, from the initial side to the terminal side where we would finish that rotation, okay? So initial side, vertex, and terminal side, you can see in this diagram here, as well as this idea of standard position. Okay, positive angles versus negative angles. So let's say we have two angles in standard position, both with their initial side right here along the x-axis. And we take a positive angle, which rotates counterclockwise. This would be an angle that looks like it's a little bit more than 90, maybe 120 degrees. And then we've also got a negative angle. This looks like about a 45-degree angle. We would call this angle negative 45 degrees. So if I were to name these angles, let's say the first angle I called alpha. Estimating, I would say alpha is about 120 degrees. Let's call this angle here beta. I would estimate beta to be about 45 degrees, but since it rotates clockwise, I would call it negative 45 degrees. So that's the difference between positive and negative angles in standard position. Now, angles can be in any position, but standard position is the one we work with most often. So let's talk about now coterminal angles. That means two angles that terminate at the same place. So let's look at angle A. Let's say that angle A, or angle alpha right here, is 45 degrees. Angle beta is definitely not 45 degrees, but they terminate. Both angles, alpha and beta, terminate at this ray right here, that terminal side. So I could calculate beta by taking alpha plus another 360 degrees. So it looks like beta, I'll go with yellow, beta would equal alpha plus 360. So that would be, I believe, 405. That's an example of coterminal angles, right? If they are 360 degrees apart or a factor of 360 degrees apart. Here's another example. Here's alpha. I would say alpha is about, it's 180 plus about 45. So let's say 225. And let's call beta, then that would be negative, since it's a negative angle, 135. Okay, so if I added 360 to beta, I would get alpha. All right, so if you were to add 360, let's add 360 to beta visually. That would be 360 degrees, a full rotation. If I added 360 and negative 135, I would get 225. Those are coterminal angles. Okay, complementary angles, something you should remember from geometry. Two angles that add up to 90. So an example of a pair of complementary angles would be alpha equals 60 and beta equals 30. Now with complementary angles, both have to be positive angles. So you can't have This is a counterexample. This is not a pair of complementary angles, but you can't have 110 and negative 20. That's not going to work. Both angles have to be complementary. Therefore, that means both angles have to be acute, which means less than 90. Let's talk about supplementary angles. Very similar. Supplementary angles add up to 180, also known as a linear pair. So let's say this is 60 degrees alpha. Then if alpha and beta are supplementary, let me do yellow, it'll show up a little bit better, then beta should be 120. Okay, so to have supplementary angles, both angles have to be, well, one of the angles will either be 90 degrees or less, and the other will be 90 degrees or more, okay, in order to make a pair of supplementary angles. Now, you could have three angles that are supplementary, and then all three would potentially be acute angles. But in this case, one of them would be obtuse. Okay, let's get off of the vocabulary and get into the material for this lesson. So let's get into the idea of a radian. Now, a radian is a different way to measure an angle. Let's go through the definition and we'll look at some examples. A radian is a measure of a central angle that intercepts an arc equal in length to the radius r of the circle. So if you look at the visual I've got here on the top left, if I were to stretch out the radius, I could actually take the radius and stretch it out along the edge of the circle just over 6 times. And actually, the length around a circle is about, right, the circumference is about 6.28 radii, which we know to be 2 pi r. Now the angle, any angle here, let's call this theta. Right, for example, this angle right here, this angle right here would be 1 radian, okay? So theta will always be equal to the length of the arc. Let's call S the length of the arc, over the radius. Okay, so our angle in radians will always be the arc length over the radius. Okay, so if you were to have to convert from radians to degrees, okay, half of the circle is pi radians. That's equal to 180 degrees. The full circle is 2 pi radians. That's equal to 360 degrees. Therefore, our conversion is pi radians per 180 degrees. So let's look at the diagram below with this in mind. So if I have an angle in the first example, this angle right here, of pi over 6 radians. Pi over 6 radians would be equal to how many degrees? We're going to do conversions on that in the next few slides to come, but let's think about that. All right, pi over 6 is, let's look at this, 1, 2, 3, 4, 5, 6, 1/6 of a half of a circle. Well, we know that a half of a circle is 180 degrees. So if I take 1/6 of 180 degrees, I get 30 degrees. We're going to use a different conversion method here in a little bit, but it starts to give you a visual. If you could visualize, 2 pi will be 360, pi will be 180, pi over 2 should be 90, pi over 3 ends up being 60, and pi over 4 ends up being 45 degrees. Okay, let's move on to the next slide and see what we got. So from the definition of a radian, right, I can find the measure of a central angle, theta, by taking S over R, where S is the arc length and R is the radius of the circle, and theta is the measure of the central angle Okay, always in radians, always. Okay, so if I have a circle, and I have, let's say, a radius of 5 inches, and I have a theta value of pi over 6, right, that's my angle. I could find the arc length S, right? What would the arc length be if the angle was pi over 6 and the radius was 5? Well, I can take this equation and solve for S. Multiplying both sides by r, the arc length will be r times theta. So this arc length would be r times theta. So the length of that arc would be 5 pi over 6 inches, right? That's the length of that arc. We're going to do a little bit more of that into the later parts of this lesson. So let's go ahead and move on. All right, so a little bit of practice in example 1, sketching the angles in standard position and determining what quadrant they land in. So let's talk quadrants and then we'll sketch. This is quadrant 1, okay? Quadrant 2, quadrant 3, quadrant 4. All right, so we're going to start our angle. Let's start our initial side right here. We're going to rotate 45 degrees. And here's our terminal side. Okay, so there is a measure of theta equal to 45 degrees. Just FYI, that means theta is also equal to pi over 4 radians. Okay, let's do the next example. Oh, by the way, that angle falls in quadrant. You can say Q1. Okay. Let's go with negative 120. We'll start in standard position with our initial side there. We're going to rotate clockwise due to the manner of the negative angle. Now, notice that this here would be negative 90 degrees. We're going to go past that 30 degrees. So we're going to rotate probably right about like that. Theta will equal negative 120. Here's our terminal side. I went a little overboard there. Let's go from the vertex. There we go, from the origin. Perfect. That'll land in Q3. Okay, if you're curious, theta would be negative 2 pi over 3. We'll get to conversions in a little bit, like I said. Okay, so 230. Let's put our initial side. We're going to rotate counterclockwise. Now this angle is 90. We're going to go past that. This angle is 180. We're going to go past that. We're going to go past the second, what we call quadrantal, 50 degrees. 50 degrees. Okay, so you can think of this as 90 degrees, another 90 degrees, which is 180, and another 50 degrees. So that angle theta is 230 degrees. That will land also in quadrant 3. Okay, let's go to example 2. Determine 2 coterminal angles for each angle given. Okay, so negative 95, let's visualize that first. Okay, negative 95, here's our initial side. Angle of rotation will go just a little bit past there, and we'll get our terminal side. So theta equals negative 95. Now there's 2 ways I could get to that, or at least the 2 closest ways. The first way is I could do a positive angle of rotation right there and get some other theta value. Okay, how I can get that, right? How I could get that angle is I could rotate this way 360 degrees, which means add 360 degrees to negative 95. So let's do that. Negative 95, oops, plus 360. I always add, or I'd subtract 100 and then add 5. So subtract 260, add 5, 265. Okay, so a coterminal angle, this should actually be in yellow, would be 265 degrees. Okay, another way to get a coterminal angle, instead of adding 360, is subtracting 360. So my other coterminal angle, I would subtract 360, and I believe that would be a negative 455. All right, so what would negative 455 look like? Let me sketch it here. And initial side. And here we go. We're going to pass the original terminal side. So there's negative 95, and we're going to go another 360. So that would be theta equal to negative 455. There's two coterminal angles. So now that you know what we're doing, let's add 360 and let's subtract 360 to find those two coterminal angles. I've asked you also to put these in radian measure. I think we'll get to that in a little bit, so scratch that for just a moment. Okay, so add 360. That would be 210. There's one coterminal angle with negative 150. Subtract 360, that's going to be 510. Excuse me, negative 510. There's your other coterminal angle. With 225, I add 360, and I get 585. And I subtract 360, and I get, oh boy, 100, negative 135 degrees. Perfect. That's how you find coterminal angles. Those are just angles that terminate at the same place. They just take a little longer to get there, or possibly shorter depending on the orientation. Okay, let's keep moving. All right, two angles are complementary if their sum is 90. Now the two angles have to be positive angles. Okay, we've talked about that on the very first slide, but we'll go ahead and get into that again in a minute practically. Two positive angles are supplementary if their sum is 180. Let's find complementary angles and supplementary angles for each angle given if applicable. So if the angle is not less than 90, we can't find a complement, and if the angle is greater than 180, we can't find a supplement. So let's take 38 and find its complement. So its complement would be 38 plus some angle measure is equal to 90. That looks like x would be 52. So 38's complement is 52. Its supplement, 38 plus y, is equal to 180. Okay, so if I subtract 38 from 180, I get 142. So there is the complement and the supplement to 38. Now in number 2, there won't be a complement, right? Because that angle measure is greater than 90 degrees, but there will be a supplement. So let's look at what the supplement to 114 would be. So 114 plus y is going to equal 180. That looks like y will equal 66 degrees. Okay. Ooh, how about number 3? Now we haven't gotten to this yet, but we can work through it. We'll get it. So a complement. Well, 2 pi over 3 plus x has to equal pi over 2. Well, we have a problem here. 2 pi over 3 is actually larger than 90 degrees. So 90 degrees is pi over 2. Therefore, the complement will not exist, but the supplement will. So 2 pi over 3 plus y is equal to pi. Now, we have to get a common denominator to find the supplement. All right, so the supplement, let's see here, this would be 2 pi over 3 plus y is equal to 3 pi over 3. If I subtract 2 pi over 3 from 3 pi over 3, it looks like the supplement of 2 pi over 3 is pi over 3. Awesome. Okay. Let's look for complement supplement here. There won't be a complement. This number is greater than 90. And there won't be a supplement because this number is greater than 180. So neither there. All right, how about a complement for pi over 12? Well, pi over 12 plus x equals pi over 2, right? That's 90 degrees. So let's get a common denominator. That's pi over 12 plus x is equal to 6 pi over 12. Therefore, x is equal to 5 pi over 12 when I subtract. That's our complement. Let's look at our supplement. Pi over 12 plus y is equal to pi. So pi over 12 plus y is equal to 12 pi over 12. Common denominator tells me that the supplement to pi over 12 is 11 pi over 12. Very cool. The last one is numbered incorrectly. That should be number 6, so VI. But 2 radians, where does 2 radians fall? Well, let's think about this for a second. Pi over 2 radians is equivalent to 90 degrees. Well, that's 3 over 2. That's a little less than 2. So this 2 radians will fall in quadrant 2. It'll be over here. So there is no complement to 2 radians, but there is a supplement, right? Because we know that 180 degrees is pi units. And 2 is less than pi. Pi is about 3.14. So let's take 2 plus y and set it equal to pi. Right? Because 2 is not 2 degrees, it's 2 radians. Pi is 3.14 radians, so y would have to be pi minus 2 radians. That's kind of odd, kind of weird, but you could say 1.14. That would be the number of radians that would be a supplement to 2 radians. Okay, that is supplementary complementary angles. All right, so let's get to the good stuff where we convert back and forth from degree to radian or radian to degree. Okay, so if we want to convert 38 degrees from degrees to radians, recall before we said pi over 180, right? Pi radians per 180 degrees. Or we could use 180 degrees to pi radians. So if I want to convert from degrees to radians, okay, let's make this clear. Degrees to radians, I'm going to use pi over 180 as my multiplier. If I want to go from radians to degrees, 180 over pi will be my ratio that I'll use. And I'll show you what I mean here. So if I multiply 38 by 180, or by pi over 180, what you'll notice is that the degree measures will reduce. So what I would get in radians would be 38 pi over 180 radians. You can write rads. Now I'm going to reduce that. That reduces down to 19 pi over 90 radians. Okay, now let's take 114. We're going to use the same multiplier, pi over 180. Let me get my red marker out here. There we go. And again, I'm going to reduce. So 114 times pi over 180. Something awesome that you can do on your calculator is take 114 divided by 180, and I get 0.63 repeating. If you press the math button on your calculator and then option number 1 that says frac, it'll reduce the fraction for you. And it did all the math for me, provided your calculator is allowed. You would get 19 pi over 30 radians. Okay, let's convert 2 pi over 3 now to degrees. Okay, so I'm going to multiply by 180 divided by pi. You'll notice that the pi's reduce. Pi's will reduce, and what I get is 2/3 of 180, which is 120. Okay, I have now converted 2 pi over 3 to degrees, which is 120. Okay, let's go back to degrees to radians. So I'm going from degrees to radians. And this one is not very nice. I don't think it's going to reduce very nicely. 183 divided by 180 is 1.016 repeating. If I reduce that fraction, I mean, it reduces, it's just not very nice. So I get 61 pi over 60. That's not a very typical angle measure to be asked to convert, but it is what it is. Okay, so let's convert pi over 12. I'm going to take that and multiply it by 180 over pi. Basically, what you're trying to reduce out is going to be in the denominator. And what I'll get here, pi's will reduce. I'll get 1/12 of 180. And 180 divided by 12 is 15. So pi over 12 radians is 15 degrees. Just like we did earlier, 2 radians. If I want to go from radians to degrees, I will multiply by 180 over pi. This won't reduce quite as nicely as I want it to, and that's totally fine. I will get 2 times 180 over pi, which will equal 360 over pi degrees. Now, you could leave it like that, or you could actually divide it out. And using my calculator, I get an approximation. I'm going to go to 3 decimals, which is 114.592 degrees. If it asked you to go to the nearest degree, go 115 degrees. That's converting from degree to radian and the other way around. Okay, let's work a little bit with arc length and the central angle. So given a circle with a radius of 4 inches, let's sketch it to the best of my ability. There's a radius of 4 inches. Find the length of the arc intercepted by the central angle given. Okay, so 210 degrees. You have to make a decision here. I'm going to do an angle of rotation. It's positive angle of rotation. It's going to go past 180, 30 degrees. Okay, so here's my terminal side. Theta here is 210. My initial side was this length here, and what I'm seeking is the length of the arc. The length of the arc is S. So recall that S equals R theta. Now, one thing about theta though, when you're working with this formula, theta has to be in radian measurement. So that means I have to convert 210 to radians. So I'm going to multiply by pi over 180. Okay, and just so you know, that converts to 7 pi over 6. Okay, so theta equals 7 pi over 6. Therefore, our arc length, S, which will keep the same units as the radius, which is 4 inches, will be R, which is 4 times 7 pi over 6. So S will equal, that would be 14 pi over, uh-oh, my pencil just ran out. Okay, I'll be back. 14 pi over 3 inches. Okay, or if I went to the nearest whole number, that would be about 15 inches. Okay, now think of this logically for just a second. I can go approximately 3 fours, right? That's 4, that's 4, that's 4. And then I'd come around here. Oops, I went a little short there on my approximations. Okay, so 4 and 4 and 4, and I'd be right about here for my 4th 4. So 4 and 4 and 4, and almost 4. A little less than 4. And look at that, my measurement is actually 15 inches, so it's a decent approximation just to try to visualize it. Okay, so let's do 120. Again, circle, same radius, 4 inches. This is my initial side of my angle. I'm going to rotate 120 degrees, which is just past 90. So this will be 90 degrees. I'm going to go 120. So theta is 120, which converts 120 times pi over 180 converts to 2 pi over 3. Therefore, the arc length will equal r times theta. So 4 times 2 pi over 3, which will be 8 pi over 3 inches. Now 8 pi over 3, you could definitely approximate by just using that method with stretching a radian out, but I get approximately, well, if you think of pi divided by 3, that's about 1. This comes out to be about 8 inches. It's about 2 radians. Okay, let's do the last one here, and we'll move on to our last slide. Okay, circle, radius 4 inches. Standard position, we're going to rotate negative 150, which is going to go past negative 90. And terminate, oops, I got my green and my blue flipped around. That should be a 4 in green and in blue. So we want to know the measure of this arc. Now, interestingly enough, it doesn't matter if your angle is negative or positive. So in this formula, we can ignore whether the angle is negative or positive. So if you could visualize this, if I had done a positive angle of rotation, same measurement, those arcs should be the same length, right? But just by symmetry alone, that makes sense. So I'm going to take r, which is 4, times theta, which is negative 150 times pi over 180. This converts to negative 5 pi over 6, but I'm going to actually take the absolute value of that, negating it. You don't really have to think of it as absolute value, but I just want you to know that it doesn't matter that it's a negative angle of rotation, because the arc length is still a positive length. So that would be, oh gosh, what would that be? 10 pi over 3 inches. All right, guys, let's move on to the last slide here. Okay, so here we are, example 6, last page of this set of notes. I just want you to look at each of the sectors. These are both sectors, angles of rotation in red, radius along that radius value. You can just assume that the vertex is located here and here. That's the vertex of the angle in standard position. I'm expecting for this arc to be obviously clearly a little longer than that. So I'm expecting this angle to be a little greater than 1 radian. Okay, so let's use our formula. Now we have s equals r theta, but we also have the formula theta equals s over r. Therefore, theta would be s, which is 6, over r, which is 5. So theta is 1.2 radians. Okay, likewise, in the second example, I'm going to use theta equals s over r. S is 32 over r, which is 7. It's going to be a little short of 5 radians. Okay, so theta will equal, what would that be, 4, oh gosh, 4 and 4/7 radians. Now, I would never write radians in that mixed number form. I would just take 32 divided by 7 and get the actual radian measure out to 3 decimals. So that'd be 4.571 radians. Okay, example 7, find the radius of a circle with an arc length of 36 and a central angle of 135. Let's do it quick. Arc length of 36, central angle 135. Now you could put your central angle wherever you want it. I'm going to put it in standard position. So I don't know the radius length, but I do know that I have an angle of rotation of 135 degrees. That's theta. And I got my terminal side, and I got an arc length of 36. It's 36 feet. Now, just recall that we need theta to be in radians. So I'm going to take 135, multiply by pi over 180. You're going to start to get good with converting, but 135 is 3/4 of 180. So I'm going to have 3 pi over 4. Therefore, if s equals r theta, then r equals s over theta. Therefore, r is going to equal s, which is 36, that's the arc length, over theta, which is 3 pi over 4. Let's do a little algebraic manipulation here. So when I divide by 3/4, that's the same as multiplying it by 4/3. So let's take 36 times 4 over 3 pi, and let's reduce. So if I reduce this, I get a 12. So that looks like it's 48 over pi inches. Nope, feet, sorry. I shouldn't do that in red. Let's do it again in green. R equals 48 over pi feet. Now, in exact form, you'd be done. Approximated form, 48 divided by pi is, out to 3 decimals, 15.279 feet. Okay, guys, that's our lesson. Degrees, radians, arc length, and all that good stuff. So hope it made sense. Let me know if you got some questions. We'll see you in the next video.